Okay, guys, I want to just take you through the analysis now of a function that uses the extrema, okay, as demonstrated by this particular example that we see here. Okay, so this is straight out of the PowerPoint that I originally posted. Let's just walk through it together just so you get a clear picture. I can hopefully clarify any thoughts you may have had in your mind over this. So we got this function, f of x equals 3x to the power 4 minus 4x cubed. And what we want to figure out is all global maximums and minimums, as well as local maximums and minimums that occur in this function over the interval of -1 to +2. Okay, and we'll do the analysis, and then we'll look at a graph on Desmos just to prove it. Okay, so here's the analysis. What we'll do is we will just open up a quick little notepad so that we can look at this information. And remember that our function is f of x, right? F of x is equal to 3x to the power of 4 minus 4x cubed. And let's just do all of the necessary groundwork really fast up front. F prime of x is equal to 12x cubed, just using the power rule, right? 12x cubed minus 12x squared. And f double prime of x is equal to 36x squared, 36x squared minus 24x, right? Okay. So what we got to do is we first of all want to analyze the ends of our interval. Remember that the graph is being analyzed over the interval where x is an element of or belonging to -1 to +2. Okay, so if that's the case, it turns out that f of -1, if you were to plug it into the function, would actually equal 7. Okay, it also turns out that on the right-hand side of the interval, f of 2 is equal to 16. Right, so that's how our graph ends off. Visually, what does that mean? Well, from a rough sketching point, we might have a point here, we might have a point here. Okay, next, we're going to take a moment now to set the first derivative equal to 0, because by setting the first derivative equal to 0, what we actually find out are x values on the graph that produce a 0 slope. And when a graph has a 0 slope, it can mean one of two things: a turning point, right, where a graph goes either like this or like this, right, or a point of inflection where a graph might go like this and have a flat curve. So, a point of inflection will not correspond to a maximum or minimum, but a turning point would. Whether the turning point is a global maximum or minimum is dependent upon, the other intervals in the graph. Of course, I can envisage one scenario maybe where a point of inflection would be a maximum or minimum, and that would be if the point of inflection itself was the end of an interval, but I don't think that's going to be happening here, okay? So anyway, we got to set the derivative equal to 0 and then solve for x, and that will give us places on the graph where the slope is 0, and this graph can be solved graphically by factoring. So I'm going to say 12, I'm going to factor out 12x squared. I'm going to have actually x minus 1, and I'm going to use what's called the zero product rule, and I'm going to say 12x equals 0, so x is equal to 0, and also x minus 1 equals 0, so x equals 1. So at x equals 0 and x equals 1, the graph has a 0 slope. Fair enough. What does that mean to us? Well, we've got to find out. So now we're going to do a second derivative test, and I'm going to take these two values and plug them into the second derivative. So f double prime of 0 turns out to be 0. That means that when x is equal to 0, the graph is neither concave up nor concave down. If the graph's not concave up, or concave down. The only other possibility is the graph just flattens out but doesn't change concavity, which means that we have a point of inflection. So we're going to shorten that to POI. So this is not going to be then something that shows up as a maximum or minimum in our graph, okay? And it's not the endpoint of the interval, because the interval, as we saw earlier, goes from -1 to 2. So this is going to be an insignificant point. This point will end up being insignificant in terms of our analysis of extrema. What about f double prime of 1? Well, f double prime of 1 turns out to be -1. F double prime of 1, it's my fault. F double prime of 1 does not turn out to be -1. F double prime of 1 turns out to be, sorry about that, it turns out to be +12. Turns out to be +12. Okay, what does that mean? Well, that means that it's a positive result, which means the graph is concave up. If it's concave up, that means that the slope is 0 in a concave up situation. That means that f of 1 must be some kind of minimum. Is it global or is it local? Well, we're going to find out in a second. Okay, so now back to analysis. Here is what we know. From our analysis done thus far, we know that f of -1 is equal to 7. And we know that f of 2 is equal to 16. We also now can take a moment and figure out what is f of 0, our point of inflection. Well, f of 0 actually turns out to be 0, and f of 1, the point that we found produced a minimum, turns out to be -1. That, if you'll notice, everybody, that's the lowest output value that we've experienced so far. Okay, so just looking at our very rough sketch of the situation thus far, here's what we might want to make note of. We might want to make note of, we have a graph. When x is -1, y is 7. I apologize for the roughness of the sketch, but f of 0 produces a value of 0, f of 1 produces a value of -1, and f of 2 produces a value of 16. So we might have a graph looks something like that, right? Stopping here and here. Okay, I guess here, right? Okay, so what would we conclude from this? Well, we would conclude that this point would be our global maximum, and we would conclude that this point would be our global minimum. This is a point of inflection, which is insignificant, and this right here is an end of the interval, which is also insignificant. So conclusion made without drawing a Desmos graph is we have a global max at the end of our interval at the point 216, and we have a global min as identified by our first and second derivative test located at 1, -1, and there is no local minimum or no local maximum, and there is a point of inflection, but that is not relevant here. The other endpoint, as we said, where x is equal to -1, producing a y value of 7, insignificant because it is not the highest or lowest point. Now we're going to end off this video by just proving this fact on Desmos. Okay, so let's go over to Desmos here and hope and pray that it works, because you never know with technology these days. It's always okay. So I go to Desmos and well, what do you know here? Let's see. Well, I'll get Desmos to interact with me. You might see the graph as it is right now. I don't know, but let's see. Okay, so we go here, and you know what? There it is. There it is right there, okay? I've drawn the graph in. I have put the intervals in. You can see you got your maximum value here. Yeah, Desmos is kind of frozen, I know it. But this point is 216. And you've also got your other end of the interval here, which is -1.7, right? And just trying to like basically look at this. You've got your absolute minimum here, which is your global minimum, okay? And yeah, so I hope you found that helpful. Thank you guys for watching. Have a great day.